everyone. My name is Kimberly Ames, and this is my physics final project. I designed a concept called Aurora Net, which is a system that combines energy harvesting and power grid protection by using space weather, specifically auroras and geomagnetic storms. This project explores how physics concepts like electromagnetic induction, magnetic fields, and energy transfer can be applied to a real world problem that affects modern infrastructure. What is space weather? So you can see my contents here. We're going to talk about space weather. Space weather refers to environmental conditions in space that are influenced by the sun. Events like solar flares and coronal mass ejections send charged particles toward Earth. When these particles interact with Earth's magnetic field, they create auroras, which are beautiful, but they can also cause serious problems. Rapid changes in Earth's magnetic field can induce unwanted electrical currents in long power lines, which can damage transformers and disrupt power grids. The problem is modern power grids are especially vulnerable during geomagnetic storms. These storms can create what are called geomagnetically induced currents, or GICs, which overload grid equipment. This is a real concern for high latitude regions and long distance transmission lines, and outages can be expensive and difficult to repair. So the challenge is, how can we protect the grid during these events instead of just reacting after damage occurs? Introducing Aurora Net. Aurora Net is my proposed solution. It is a network of high altitude platforms and small satellites positioned in regions where auroral activity is strongest. Instead of treating geomagnetic storms as purely dangerous, Aurora Net treats them as an opportunity. The system captures energy generated by rapidly changing magnetic fields during auroras and using that energy to power grid monitoring and protection systems exactly when they're needed most. How energy harvesting works. The main physics principle behind Aurora Net is electromagnetic induction, which is described by Faraday's law. When the magnetic field around a conductor changes, it induces a voltage. During geomagnetic storms, Earth's magnetic field changes rapidly, which makes those conditions ideal for induction. Aurora Net satellites use induction coil arrays that experience changing magnetic flux during auroras. This induces electrical energy, which is stored using supercapacitors or batteries. The system can also adjust coil orientation to maximize magnetic flux, which improves efficiency during storm conditions. Grid production function. The harvested energy isn't meant to power cities. Instead, it's used for grid protection. Aurora Net helps by powering real time monitoring sensors, early warning systems, and emergency communication link for utility operators. This allows the grid to enter a kind of storm mode where operators can reduce load, reroute power, or isolate vulnerable equipment before damage occurs. I'm not going to read all of this here. Um, What makes Aurora Net innovative is that it combines energy harvesting and grid protection into a single system that only activates during geomagnetic storms. It's self supporting during critical moments using existing technologies like satellite and induction coils and doesn't require permanent land based infrastructure. Feasibility and future potential. While Aurora Net is a conceptual system, it is based on real physics and existing technology. Space weather satellites already monitor geomagnetic storms, and grid protection systems already exist. As satellite design, energy storage, and AI based prediction improve, a system like Aurora Net could realistically be implemented in stages, starting with pilot networks in high risk regions. Reflection and conclusion. This project helped me understand how physics concepts like magnetic fields and electromagnetic induction directly affect modern infrastructure. I enjoyed being able to combine creativity with real science, and it made the material feel more relevant and practical. Aurora Net shows how physics can be used not just to explain natural phenomena, but to design systems that improve resilience and sustainability. Thank you very much for watching.